so I think we will begin. I'd just like to welcome you and tell you that I am Amy Janess, Programming Coordinator for the Nantucket Atheneum, which is the public library on the island of Nantucket in Massachusetts. Before we begin tonight's presentation, I just would like to play a short video that pays tribute to the founders of the Geschke lecture series, of which tonight's event is a part, and honors in memoriam Chuck Geschke, the co-founder of Adobe Software, a former Atheneum board member, and the namesake of this lecture series. So let me just share my screen.
The Nantucket Atheneum is a stronger and more vibrant library because of Nan and Chuck Geschke's vision and generosity. Chuck revolutionized software development, co-founding Adobe Inc. and the PDF with John Warnock. He received many awards, including the nation's highest honor for technological achievement, the National Medal of Technology and Innovation. He and his wife, Nan Geschke, a former librarian, served on the Atheneum's board in the early 2000s and have supported many of the island's nonprofits as major donors over the decades. Chuck and Nan helped bring Circus Flora to the island as a fundraiser for the Atheneum and later matched a National Endowment grant for the creation of the Geschke Lecture Series in 2005. Chuck and Nan's leadership has provided a solid foundation of excellence, and 16 years later, the Geschke Lectures have become the premier event to experience fascinating conversations around cutting-edge ideas. And all throughout, Chuck and Nan have remained involved in planning the series, as well as attending every lecture. For all that Chuck Geschke has meant to the Atheneum, to Nantucket, and to the community far beyond, we thank you and Nan and honor your legacy as we go forward with this evening's lecture and all that are to come.
Okay, and just one little housekeeping thing. We will be taking questions at the conclusion of the program tonight. So as we go along, if you think of a question, please put it in the Q&A, which you'll find at the bottom of your screen. You'll see a little icon that says Q&A. Click on it and type your question in there. And we will attempt to answer it when we get to the end of the night. So just a little bit by way of introduction, I'm going to tell you a little bit about our three presenters tonight, and then we'll start. So tonight we are honored to feature Dr. Neal Kassell, John Grisham, and Jane Metcalf. By way of introduction, here's a little bit of background information. Dr. Kassell is the former chair of neurosurgery at the University of Virginia, as well as the founder and chairman of Focused Ultrasound Foundation in Charlottesville, Virginia. In 2016, he was named to the Blue Ribbon panel of the Cancer Moonshot Initiative by then Vice President Joe Biden. He's published more than 500 scientific papers and book chapters, and his research has been supported by over 30 million in NIH and industry grants and contracts. Since first publishing A Time to Kill in 1988, author and attorney John Grisham has written one novel a year, which, when his latest book comes out in October, comes to 37 books for adults and 7 children's legal thrillers in the Theodore Boone series. Mr. Grisham serves on the Focused Ultrasound Foundation board and has written a non-legal thriller called The Tumor, a book that illustrates for readers how this new technology could change medicine forever. And Jane Metcalf, our moderator this evening, joined the board of Focused Ultrasound Foundation last year. She's the co-founder of the media company Wired and served as its president. Currently, she is CEO of Neo.life, a media and events company she founded that tracks the radical changes taking place as humans harness engineering tools and computer science to alter their own biology. So please join me in welcoming our panel tonight, and take it away, Jane.
Hi, thank you, Amy. It's lovely to see you and everybody here. I'm super honored to be participating in this event. Chuck Geschke and John Warnock had a huge impact on my career. In fact, PostScript, which is the language and the PDF format, are what enabled us to publish our little cult magazine with a tiny little staff and a tiny little budget in Amsterdam. And that magazine became the forerunner of Wired magazine, which again relied entirely on Adobe software. So it's really an honor to be here doing something that I know was important to him and his wife. I also want to say how amazing the Atheneum is and how much I regret because of COVID that we couldn't all be there in person. It's a magnificent building, and I think would have been a wonderful place to have the conversation. But I understand this is the first time the lecture series has begun since the pandemic. So opening up again, which is great, even if virtual. So we're here tonight with two friends who know each other quite well. I've gotten to know Dr. Kassell over the last year and a half, and I invite them to interrupt each other, to interrupt me, to ask each other questions. I've got a list of things that I hope we will cover, but it doesn't have to be a formal one-way kind of conversation. So I just want to say, first of all, that I have enormous respect for Dr. Kassell, whose accomplishments Amy already listed. The chance to talk to John Grisham was not something I expected along the lines of my work, but it's great to have you here. And the idea that you've published a book every year and sometimes two kind of boggles my mind. You have sold over 300 million copies of your books, and you've written 28 consecutive #1 bestsellers. I don't know any athlete or anybody who has that kind of a track record. So that's great. And that's in addition, of course, to your film and television shows and your, of course, career as a lawyer and a politician. So, but you're a master storyteller, and that's why you're here tonight. So I would like you to tell us a story that begins like this. The novelist and the neuroscientist walk into a bar.
Is that all I have to go with?
That's all you got.
That's it.
That's it.
Oh, wow, that's a tough one. Well, the neurosurgeon hasn't spent much time in bars because, like my good friend Neal, he's been on call 24/7 for the past 30 years. So his bar experience is quite limited. The novelist, on the other hand, has spent most of his life in bars, as writers do. It's all fiction, right? So I'm not talking about myself. So they go into a bar together, and they order a drink. The neurosurgeon orders a Diet Coke. The novelist orders a double Scotch. The neurosurgeon is looking around. The novelist just wants to drink. There's an attractive blonde at the end of the bar, and because a neurosurgeon thinks he's God's gift to women, he decides to make a move for the blonde, and this causes problems because she has a boyfriend at somewhere around there. This leads to an altercation, and so there's a bar brawl, which the neurosurgeon has never seen before, and the novelist has been involved in many of them. Okay, and the novelist takes a beer bottle over the head. He's wounded seriously, and they haul him out in an ambulance. He goes to the hospital. He needs surgery because of a brain injury, and the neurosurgeon, his friend, is not there because he made off with the blonde, and so the novelist expires on the operating room table waiting for his buddy, and there should be a legal angle here. So the family of the novelist sues the neurosurgeon for medical malpractice. That's the legal angle. Okay, so we have a big lawsuit, and of course the neurosurgeon loses and pays a lot of money.
Okay, there were so many twists and turns where I thought you could have brought it back to what we were going to talk about tonight.
Yeah, but you got to have some dead bodies, and you got to have a lawsuit, got to have all this kind of stuff.
That's fantastic. Well, I thought the neurosurgeon, of course, would be Neal, who would come in and save, the drunken.
Yeah, and the blonde would be you.
Oh, I didn't think of that. So I assumed the blonde was John's wife, who apparently Neal hit up and convinced to get involved with the Focused Ultrasound Foundation. Oh,
That's
great.
true. She's a brunette, by the way. And Neal,
Okay.
the first time Neal sort of pitched the idea of focused ultrasound to me, I had no interest in it. I have no medical background or no, I was not intrigued by it. But he managed to corner my wife after a dinner party at his home one night and show her the PowerPoint presentation for focused ultrasound, and she really liked it, and she talked me into taking a second look at Neal's idea for focused ultrasound, probably 15 years ago. So she was involved in it. Yeah.
That's great. That's a really good dinner party trick, Neal, to pull out your PowerPoint and show your hostess. I'll keep that in mind when we host a dinner for you in the Bay Area.
Yeah.
So let's talk about, so I had ultrasound when I had my two babies, but nobody ever said focused ultrasound. And in fact, I'd never heard of focused ultrasound until our mutual friend, Mary Lou Jepson, who is an entrepreneur in the neuroimaging space, said she'd just gotten back from this meeting, and ultrasound is not just a diagnostic tool, it can actually be a treatment tool, and I should meet this guy, Neal Kassell. And so I looked him up and I thought that was interesting, and I looked at his board and I found my cousin sits on his board, Jane Ewald, who sadly has recently passed. But so I called him up and I said, tell me about focused ultrasound. And you did. So what can you tell us about focused ultrasound, just by way of introduction, and how do sound waves interact with human tissue?
Sure. Well, focused ultrasound is a totally non-invasive, early stage therapeutic technology. And as you talked about, you're familiar with diagnostic ultrasound. Well, think of this. We're all familiar with using a magnifying glass to focus beams of light on a point and burn a hole in a leaf. But with focused ultrasound, instead of using an optical lens to focus beams of light, we use an acoustic lens to focus beams of ultrasound on targets deep in the body with a very high degree of precision and accuracy. And where each of the individual beams passes through the tissue, it has absolutely no effect because it only has the power of diagnostic ultrasound. But at that focal point where all of the beams converge, like where the beams of light converge and heat up the leaf, where all the beams of ultrasound converge, we now understand 25 plus ways in which ultrasound can affect tissue, including destroying tissue by a variety of mechanisms, delivering drugs in higher concentrations more safely and effectively than can be done in other ways, stimulating the body's immune response to cancer, and so on. And the fact that there are so many different ways in which ultrasound, focused ultrasound, interacts with tissue creates the opportunity to treat a very wide range of serious medical disorders. Unlike radiation therapy, which we're all familiar with, which only has one mechanism of action, focused ultrasound has more than 25. And today, around the world, there are more than 150 medical disorders or indications that are in various stages of research and development and commercialization. 10 years ago, there were only 3. So the field is exploding. And these indications range from Alzheimer's disease all the way to arthritis. So focused ultrasound, because of the broad range of indications which it can address, has the potential to, without exaggeration, improve the lives of millions of people around the world with a wide variety of serious medical disorders.
So I have a very specific question first, which is the point at which all of the sound waves are focused. will it burn the leaf the same way?
It can heat the tissue up at that point, or you can just use the mechanical energy of the ultrasound to create microshock waves and disrupt cell membranes. It can be used to activate drugs, particularly, precisely at that location. It can be used to damage tissue, which stimulates the body's immune response to cancer.
And so as a neurosurgeon, getting something, a drug or any kind of therapeutic across the blood-brain barrier is a huge challenge, because our bodies have evolved to protect our brains from exactly that and the risk of infection. So the opportunity to first of all, cross the blood-brain barrier using focused ultrasound, but also operate, essentially breaking up a tumor using focused ultrasound, means not having to cut through the skin and through the bone to open up the skull, but to actually treat neurological disorders in this non-invasive way. What do you think are some of the most impactful applications of this technology?
Well, the things that we are most excited about at the foundation are the neurological disorders: Alzheimer's disease, Parkinson's disease, ALS, OCD, depression, epilepsy, and brain tumors on one hand. And on the other hand, the other thing that focused ultrasound has tremendous potential is to enhance or augment the effectiveness of cancer immunotherapy drugs for brain tumors, breast tumors, prostate tumors, liver tumors, whatever solid tumor you can think of. So right now, as you may be aware, the miraculous new cancer immunotherapy drugs are effective, but only in 20 to 40% of patients with tumors. And focused ultrasound has the potential to augment that effectiveness and increase it to 60, 80, 90%.
It's an extraordinary tool that has been sitting on the shelf for many, many years, but it took somebody like you to start asking questions about how can I use this tool in a different way. We wrote a story, and maybe you could just pull up the page on our website showing the story we wrote in Neolife for just a few seconds. But we wrote a story about Dr. Kassell and the focused ultrasound, and showing the kind of history of how he got here. Neal used to actually, he's very interested in tools and used to try and get people to use a gamma knife, which is another tool that he found useful and disruptive, and things that could, you can take that down, and things that could, maybe show the illustration though. Scroll up so we can see the, there we go. Okay. Anyway, that's our story, which I highly recommend you read if you want to know more. But this focused ultrasound is the next technology that you're taking on, and rather than going discipline by discipline or field by field, you're actually showing physicians and researchers across all these different fields how this can be used, and bringing all this research together under one umbrella so that people can see what the advances are. Obviously, you've raised a lot of money. You're listed as one of the top 10 best charities in the United States, which, believe me, is a very enormous accomplishment. And you've attracted some extraordinary people to both collaborate with and support the organization. But you say, and I agree with you, that focused ultrasound has been medicine's best kept secret. John, I know you've turned your storyteller skills to write a book called The Tumor. It's super powerful, very moving. And you write about a lot of important things, notably what happens when innocent people are accused and convicted of crimes they didn't commit. But you call The Tumor the most important book you've ever written. And it's been distributed over 1 million copies. You can get it as a free download from Amazon. I understand there were some copies at the library, and the library is happy to mail copies to anybody who wants to send their address. But tell us about the book. Why is this the most important book you've ever written?
the story came about. Neal and I I think we were having lunch one day, and we were, brainstorming of ways to raise awareness. Neal asked me to join the board 10 years ago, and I was hesitant because I have no background in medicine or really science. I live in the legal world. That's why I enjoy spending my time and looking for ideas, studying issues, reading about problems in the criminal justice system and civil justice system, and ways that we can improve it. And so sometimes I write issue books about novels about stories that are designed to bring awareness to things like wrongful convictions and capital punishment and mass incarceration and sentencing disparities, all these issues that I care about. And sometimes the books, are effective in raising awareness. And Neal asked me to join the board years ago just to try to raise money. I told Neal, I can't help you with the science or the medicine, but I'll try to help you raise money. And we've been successful at that, and are still doing it. But we had the idea of trying to use the storytelling talent to tell the story of a brain tumor. Focused ultrasound got started 15 years ago with the idea of developing the technology to zap, and that's one of our medical terms, zap brain tumors, to be able to yeah, that's as far as I can go. But to be able to use the technology to go in and shrink brain tumors, and to give people extra years of high quality life before the tumors take over. And so I wrote this story about a 35-year-old young man who's stricken with a glioblastoma, which Neal operated on for 40 years and knows very well. And he knows he's had thousands of patients who've suffered from those brain tumors. And the first half of the book takes the reader through the initial stages, the seizures, the surgery, the surgery, the radiation, the meds, the steroids, and all the stuff you pour into treating the horrors of a brain tumor, and you're going to last about 12 months. That's about what you're going to last with a glioblastoma. That number hasn't changed much in the last, decades, Neal. And so young man dies. He has a young family, and it's very sad. We all know someone who's been through that. And then the second half of the book says, okay, what if we had focused ultrasound where we wanted to be in 5 or 10 years? We're getting there. We're doing clinical trials now to get there on brain tumor patients. But one day soon, we hope, 5 years, 10 years, when the technology is there, when it's approved, when we can use it for these very sick people, to be able to treat the tumors and to give people 10, 15 additional years of high quality living, just by being the tumor becomes chronic and not fatal. It's going to be treated over and over and over because it's never going to go away. But it can prolong the life of a young person for a long time. And so that's the story I told. It's heartbreaking initially, but that's what we see with glioblastomas and brain tumors. And it's also hopeful in that one day we can have the technology. That's what we're working for every day through Neal's foundation, is to raise the money, to push the research, to do the trials all over the world. And they're being done all over the world now to zap not only brain tumors, but breast tumors, prostate tumors. There are over 100 applications now that we're researching. And so that's my role in the foundation, is to raise awareness, which it's easy for me to tell a story, but also to raise the money. And that's one reason we're working hard every day to raise money for research.
And what's the scale of the budget that you're raising? How much money are you raising? How much comes from
We've raised about, I don't know, 75 million in the past 10 years. Yeah, we'd love to have 100 million. We could really use, and we're getting there. We're raising a lot of money, but every dollar helps. But we could use. What's our goal, Neal? 100 million over the next 5 years.
So our budget's about 13 million a year, of which 65% is for research, and over the years. But so we set out, we had a goal of raising $60 million over 5 years. and we're at 47 million now.
Fantastic. Yeah. So start moving the goalpost, right?
Exactly.
Yeah.
So the glioblastoma story is particularly moving because of, how invasive the surgery and the chemotherapy and the radiation can be. And the idea that you could actually go get a treatment and the next day go for brunch with your family is just mind-boggling. But what do you think are some of the most promising future applications, or ones that are coming online? So there's a complex process, right, where you have to do the initial research to discover how to use this technology. Then you have to get it proven in a lab situation. Then you have to prove it in a clinical situation. Then you have to get it approved by, the Food and Drug Administration. Then you got to get it in use in daily medicine practice, and then you got to get it reimbursed by insurance. So actually, this might be a good time if you could pull up that slide, what the Focused Ultrasound Foundation calls their rainbow graph. This actually will show you, it's a very impressive global scale look at all the different ways focused ultrasound is being tested to address these various disorders. So Neal, can you speak to this slide? What does this slide say about?
So there's two really important points here. The first is the large number of indications in various stages of development. As I said previously, more than 150. And of the 100, and as I said, the number is growing rapidly. Of the 150, about 32 or 33 have regulatory approval around the world, 7 by the US FDA. And now a handful have reimbursement, both from government and private insurance. So point number one, the large number of indications. Point number two is you can see that the majority are in early stages of evolution. And that is just a manifestation of the fact that this is a new field, it's young, and it's evolving, and that we have a lot more work to do to bring these other indications across the finish line. And the ones, as I said, that we're most excited about are the brain indications and the cancer indications, cancer immunotherapy, including glioblastoma, and particularly emphasis on pancreatic cancer, because glioblastoma, pancreatic cancer, there's been so little progress in the last 20 years. Mm-hmm. But it includes everything, including arthritis and back pain, neck pain, and so on.
So is this like a panacea? Is this a new scalpel, for lack of a better word?
Well, focused ultrasound, it is not a panacea. It's not a silver bullet. It's not for every indication, and it's not for every patient. We have to do more work to figure out where focused ultrasound will truly provide unique value in the therapeutic armamentarium. Having said that, it will revolutionize therapy. Focused ultrasound is going to revolutionize therapy to the same degree that MR scanning, which we're all familiar with, magnetic resonance imaging, revolutionized diagnosis. So this is a really big deal, but it's where MR scanning was 30 or 35 years ago. At that time, nobody had heard of MR scanning, but today everybody's had one.
Well, and the MRIs are extremely expensive, and there's an incentive for manufacturers of those scanning machines to get involved. Are those incentives true for focused ultrasound?
No. Focused ultrasound actually is one of the few new technologies, highly disruptive new technologies, that fulfills the holy grail of both improving outcome as well as decreasing the cost of care. I'll give you a couple of simple examples. Uterine fibroids, common benign tumors of the wall of uterus in young women, usually treated by hysterectomy, all in surgeon, doctor, surgeon, hospital, $25,000. Focused ultrasound treatment, $5,000 to $10,000. Parkinson's tremor, Parkinson's disease. The gold standard today is deep brain stimulation, $60,000 to $100,000 all in year one. Focused ultrasound
Plus brain surgery, right?
Yeah, focused ultrasound, $20,000 to $30,000.
Those are extraordinary savings. I mean,
Yeah.
and this is a very personal mission for you all as well. You know, I've been, unfortunately, I know people suffering from glioblastoma right now, and it struck me as far more prevalent than it actually is. And yet you guys have both struggled with that in your families, haven't you?
Well, John has had other tumors that he's dealt with, but I have a lot of personal experience, unfortunately, with glioblastoma. The incidence of glioblastoma is not increasing. It seems to be increasing, but the issue is that the incidence increases exponentially with age. We've got an aging population. We've got more surveillance, but it's such a dramatic problem.
So you're tracking all these research projects around the world and raising money to pass on to these. How do you choose which projects you support with research dollars?
That is a really, really good question. And it's really important, because if you buy into the hypothesis that focused ultrasound can improve the lives of millions of people with serious medical disorders, you also have to buy into the corollary that if we focus on the wrong disorder, we're going to end up depriving large numbers of patients. So, you know, if you want to know what keeps me up at night, it is focusing, trying to figure out which mechanisms of action have the most probability of translating into a new treatment, whether it's destroying tissue, delivering drugs, and then which of the clinical indications are truly going to be game changing. And the way we deal with it is we've got 3 tiers: segment, until you have a natural advantage, pick battles small enough to win, large enough to matter, and get points up on the board quickly so you can get some momentum going. And then at the end of the day, you know, we talk to a lot of people, everything from, you know, clinicians, scientists, patients, the payers, and make a judgment, a decision. But it is a big problem.
And sounds like a very thorough vetting process that you've systematized.
It's a thorough vetting process, but it's more art than science, to tell you the truth, right?
Well,
it's not fiction. That's his game.
Well, so John, presumably selecting which researchers to support with the dollars is not your focus, but what is it that keeps you up at night with regard to this foundation, with regard to this capability?
It's people you know who need help. And Neal gets hammered every day with phone calls from friends and strangers, mainly people he knows or has met, who suddenly have a medical emergency, some terrible tumor that's been discovered in the family, and they're calling Neal to arrange care, to pull strings and get people in certain hospitals to, you know, he spends half his time doing that. But it's also, it can be very frustrating to know this technology exists, to know it has been approved for certain applications and works beautifully, FDA approved and approved by, paid for by Medicare and reimbursed by insurance companies. 7 applications here, more in Europe, more in China, more, you know, they're ahead of us. But to know that their regulatory processes are, you know, a little more liberal than ours, but to know that there's a lot of suffering out there that could be alleviated if we could speed up the process of the research and the development of focused ultrasound surgery. And that's, yeah, I don't lose sleep like Neal does. Neal was a neurosurgeon who slept 4 hours a night for 40 years. I can't really do that. But he does lose a lot of sleep worrying about people. We had lunch yesterday at a restaurant here in Charlottesville, and he whispered that a friend of ours, a guy we know very well, was in hospice with a glioblastoma. I didn't even know that. And you think, okay, this is a wonderful human being who's had a long career and doesn't deserve this. No one deserves it, but that's going to be treated one day. And it's just a matter of getting to the goal line, and we're making progress, but we're not there yet with brain tumors. We're there with other applications. Last month, Neal and I had this wonderful lunch with a gentleman who was suffering from essential tremor, the really, really shaky hands. And we've been treating those at UVA and other hospitals for years. They're approved by the FDA. They work beautifully. They're reimbursed by insurance companies now, Medicare. And this gentleman had been suffering for 15 years with severe tremors, and it affected his whole life. And he was such a wonderful guy. It was, we were having lunch, and he struggled to eat and drink, and he kind of tried to make fun of it, but it was something he'd been living with for 15 years. And I said, tomorrow's your miracle day. He came to UVA for the treatment. I said, first thing in the morning, you're going to get this treatment that you're going to see as a miracle, because we've seen it before. We've seen many of them here at UVA. Neal has arranged all of them. And so he was treated the next morning. It went beautifully. He got up off of the table. It's not surgery. There's no anesthesia, no incision. He got up and sat up, and his hands were perfectly still. And it's a very emotional moment for these people who have struggled. And again, we've seen it enough times now to not, we still get teary-eyed because they're teary-eyed. Their lives have been revolutionized and changed dramatically by by focused ultrasound surgery. And we're doing that every day. And that's happening around the world. It's not just here at UVA, it's all over the world for these applications. So we have a lot of progress. We're making progress. We're healing people. But as the field expands, we have so many more people to treat. And that's how big the world is of our world of potential patients. And that's why I said, when I wrote the book, nothing I will ever write has the potential of improving the lives, improving the health, or even saving the lives of so many people around the world. And that's why maybe the books had a small role in that. That's why I'm, on Neal's team, on Neal's board, trying to move the ball.
Well, and it's impressive because I know someone of your celebrity and accomplishments probably gets asked to join boards all the time. And as far as I know, you're only on 2 boards, right? The Innocence Project and this one.
Yeah, I've cut back a lot. I'm on the Innocence Project for about 15 years now in New York. I just joined one other innocence group, the Centurion Ministries out of Princeton. They're a great group working to free the wrongfully convicted. And focused ultrasound, yeah, and all 3 boards are filled with members who love the work, believe in the organization, and don't want to get off the board, which is unusual in a nonprofit. Nobody wants to leave the boards because we love the work and we can see the potential in what we're trying to do.
That's so exciting. So we're going to have some time for questions. I've got a couple more of my own, but if anybody would like to ask either of our panelists about their work, their contribution, the technology, the future, please drop your questions in the chat channel and we'll keep going. So what's next for focused ultrasound, Neal? What's the next clinical trial that you're excited about?
Well, we're hoping that by the end of this year, the end of the first quarter next year, that Parkinson's disease will be approved by the FDA. There's the cardinal symptoms of Parkinson's disease, the things you normally associate with Parkinson's, the slowness of movement, the incoordination. It's already approved for the Parkinson's tremor. But the thing that is really, really exciting all of us is the whole 2 things: the cancer immunotherapy aspect and opening the blood-brain barrier. reversibly opening the blood-brain barrier. And as you mentioned, the blood-brain barrier keeps toxins and bacteria and viruses from getting into the brain. But unfortunately, it also keeps important drugs for brain tumors and Alzheimer's disease and Parkinson's disease and ALS from getting into the brain. So focused ultrasound can, in a very targeted, focal manner, reversibly for 4 to 6 hours or so, open the blood-brain barrier and allow access of these important drugs to the brain tissue or tumors that would otherwise be excluded. And we've got clinical trials ongoing for all these indications. And that is really exciting because this is a totally new way of approaching these disorders.
Mm-hmm. So you work with an incredible thing. I just have to show this to everybody. This is a document that the Focused Ultrasound Foundation generates each year. I just got my copy, and I'm blown away by the quality of this work and the extent of your impact. But there's a section here called Centers of Excellence. And this lists all of the different research institutions around the world, what research they are doing in focused ultrasound, what the status is, who the principal investigators are, how many publications have been done. Where's the Parkinson's work happening? Is it one place, multiple places?
Oh, no, it's multiple places. It's UVA, it's Weill Cornell, it's University of Maryland, Brigham and Women's, Stanford, and then a number of places in Europe as well. So the Parkinson in Madrid, there's a very, very active center.
Yeah. So I don't know if I'm like most people on this call, but I worry less about getting Parkinson's and I worry a lot about getting Alzheimer's. I mean, obviously both conditions are debilitating, degenerative, but there's been billions and billions of dollars thrown at the Alzheimer's problem with not a single valid or shall I say impactful drug, and certainly no way to reverse. We have a question from Joanne O'Keen. I've been working over 35 years with caregivers dealing with dementia of all kinds. And of course, they're looking for any treatments to delay or slow down Alzheimer's and related disorders like frontal temporal dementia or Lewy body. How will focused ultrasound help Alzheimer's?
Okay, so focused ultrasound has the potential, because it's still all on the come, the potential to stop the progression and maybe even reverse the neurological deficits of Alzheimer's disease. So as you alluded to, more than 350 drugs have been tried in patients at a cost of tens of billions of dollars. All these drugs worked in animal models, otherwise they wouldn't have been tried in humans. So all these drugs have failed. One of the hypotheses is that the reason they fail is that the drugs don't get into the brain in adequate concentrations because of the blood-brain barrier. So we've got clinical trials ongoing where we've shown that we can reversibly and safely open the blood-brain barrier in Alzheimer's patients. And we're getting ready to start the next phase of these trials and trying drugs. Mm-hmm. So is it high probability that this will be the solution to Alzheimer's disease? I don't think so, but it's a long shot, but it's a shot that must be taken because nothing else is working. Nothing else is working. And, and now there's a shift from drug discovery to drug delivery. And now we're talking about drug delivery.
Mm-hmm. So you're not talking about sending the ultrasound to break up tangles and plaques. This is more about opening up the blood-brain barrier to deliver the drugs.
Well, it's actually a little complicated because the idea is that you open the blood-brain barrier to deliver drugs. But what's happened in the animal models of Alzheimer's disease is when you open the blood-brain barrier without the drug, the amount of amyloid plaque decreases and the animals get smarter without the drug.
What?
Okay, so the question is why? But the next question is,
That's so interesting.
if you open the blood-brain barrier in normal people, will they get smarter?
Totally. I smell a story for Neal Life right there. I'm going to call you tomorrow.
Right. So, and
This
a
stuff is
related
messy,
question
isn't
is,
it?
can you
Messy.
use focused ultrasound to take Republicans and convert them into Democrats, or Democrats and convert them into Republicans? So there's a lot of possibilities here.
I think that work is happening at UC Berkeley. All right, so we've got a question here from Georgia Raisman. Do you see any usefulness for focused ultrasound on ovarian cancer, which is
Yes.
very difficult to both diagnose and treat?
Yes, and there are preclinical laboratory studies and early clinical trials in ovarian cancer, both to destroy the tumor, to deliver drugs, and to stimulate the body's immune response, immunomodulation. Yes.
That's great. I have a friend who just went through surgery on Monday, 8 hours of surgery to tackle a pancreatic tumor. Apparently, it's the same diagnosis that Steve Jobs had, only instead of hoping for holistic solutions, he went under the knife immediately. But the pancreas is notoriously difficult to reach. And then, of course, you have to cut through everything, and then you have to reattach everything after you cut the tumor out.
Yeah.
I presume that's another one that is very promising.
There's ongoing clinical trials that we're sponsoring in combination with, in partnership with the Cancer Research Institute, the Parker Institute for Cancer Immunotherapy, and so on. Very, very important.
Yeah, huge, important work. So we have two quick questions. One is the 7 specific areas in the US where focused ultrasound is approved. I actually printed this out, but maybe you know them by heart, Neal.
Okay. Prostate cancer, benign prostatic hypertrophy, uterine fibroids, pain from bone tumors, essential tremor, Parkinson's tremor, and some, that's 6. There's one more though. Right?
Arthritis? Is it arthritis?
No, not approved. Not approved.
Okay. All right. Well, that's pretty good.
Yeah.
I'm impressed.
Yeah.
And then as far as the essential tremor, can it be fully stopped or just stopped temporarily or cut back 60, 70%?
So in most patients, it stops completely. Essential tremor is a progressive disorder. So in some patients, it comes back. In some patients, it's not completely relieved, but in others it is. And it's a great treatment. And if you look not only at the score for tremor, but the quality of life dramatically improved. And there's no other treatment for this disorder. I mean, the drugs don't work, they have side effects and so on.
Jane, I'd like to encourage all the folks who are with us to go to the website. Neal and his amazing staff have put together an incredible website, and there are a lot of it covers everything, but there are a lot of videos of our patients who have gone through the treatment before and after. And the before and after videos will really, they're just very impressive and very moving to see people who are suddenly given good health back in a matter of hours. So the website is fantastic. And so please, it can answer all your questions and show you some wonderful videos.
Mm-hmm.
And I just remembered the other one is osteoid osteoma. And these are small tumors of the long bones in mostly young males. And I mean, to tell you, and they produce intractable, incapacitating pain, even though they're small, refractory to all drugs. And we had a kid who came down from Canada, multi sport athlete who was bedridden, and he literally crawled into Toronto's sick kids, was treated with focused ultrasound, and ran out the door the next day.
Wow. Wow. It's astonishing. It's just astonishing. So let's see. Here's a question from John Schwanbeck. How can we find out where open clinical trials are taking place, specifically for stage 2 and 3 brain tumors?
So as John said, if you go to the foundation's website, there's a section that says for patients, and that will tell you, you can put the name of the disorder that you're interested in, and it will tell you all of the clinical trial sites and all of the commercial treatment sites. That's one thing you can do. The other thing is you can contact the foundation, and one of our medical directors will help you navigate to the appropriate facility.
And for those of you who are not tracking what's happening in the chat channel, the website address is fusfoundation.org, Focused Ultrasound Foundation.org. So what is the biggest dream you have for this technology, Neal? I mean, you've been working on this and developing it, researching it, promoting it for the last 15 years. What is your most outrageous dream for this?
Well, the vision all along is that we will create a revolution in therapy that improves the lives of millions of people around the world with a wide variety of serious medical disorders. That's the vision, that we will, create a revolution, and the revolution has started. And there's a lot, this year, there will be about 100,000 patients treated around the world in about 800 commercial treatment sites. We're hoping that in 10 years or less, more than 1 million patients will be treated each year in about 10,000 treatment sites. And the important thing to recognize is that these fields grow exponentially. And we're at a very exciting point, because in the last couple of years, we passed the inflection point of the curve where the dialogue has clearly shifted from, if focused ultrasound is going to have an important role to play in the therapeutic armamentarium, from if to when.
Mm-hmm.
But also, just this year, we've passed the transition point where focused ultrasound historically been predominantly a research environment to just the very beginning of a commercial treatment environment.
Interesting. So we have people asking about all sorts of specific things, like, for instance, glaucoma.
Yeah, there is a company that's sponsoring clinical trials on glaucoma. You can go to the website and find out about that.
Great. Epilepsy, treatment resistant.
Absolutely. There's a variety of ways in which epilepsy is being treated. We're pumping a lot of money into that.
Oh, here's a lovely question from Susan Phillips. Dr. Kassell, I knew you when you were working at Pennsylvania Hospital as a teenager.
Oh, God.
Okay.
No, stop.
Okay, now,
No. We don't want to go down that path. This is one of the things that keeps John up at night, how he's going to keep me from appearing in one of his legal thrillers.
You were working with Dr. Langfit in the neurosurgery department. I was in nursing school. What do you think is one of the biggest improvements and outcomes in neurosurgery since then?
I think we've evolved from open surgery to minimally invasive surgery through little keyholes, now to non-invasive surgery, right?
It's beautiful. Absolutely. And you said, and I'm not going to tell what you, what about chronic neuropathic pain and chronic back pain?
Yeah, so they're good. So both, there's for neuropathic pain, there are clinical trials making lesions in the brain to stop the pain. And then there's clinical trials ongoing now for back pain and from spinal disorders and sacroiliitis.
We could go on, and and the questions go on and on about all of these different applications. And so far to every question, your answer is yes, and it's there on the website. So I think maybe these kinds of questions we can just kick back to you guys to go to the website yourself and look it up. And as Neal has said, there are people within the foundation who would be willing to talk to you about your specific situation. But maybe we can use the rest of our time here to talk about, I don't know, John's new book. John, tell us about your new book. Oh, there it is.
Oh, and Neal just happened to have a copy.
Just happened to have
it.
Is that a sign? Is that an autograph copy?
That's the advanced reading copy. No, that's the real thing, right? I gave it to you yesterday.
Oh, yeah, this is it.
Maybe you should
auction
it off to raise money for.
It comes out in October 19th. It's called The Judge's List. It's an old-fashioned entertainment. There are no serious social issues involved, no serious legal issues involved. It's an old-fashioned mystery thriller, because sometimes I get tired of writing about all the heavy stuff. And once again, in this book, whenever I run across a medical issue or need to know something about medicine, I call Neal. I'm too lazy to do my own research, so I call Neal and I ask Neal these certain questions. And so I always get a kick out of thanking Neal. In the author's note at the end of the book, I thank people who helped me along the way. And I mentioned Neal again, so he'll get phone calls from buddies around the world who see his name. And he did last year with his last book. So Neal's one of my unpaid researchers who I rely on for medical advice.
That's great. So as we close, I just wanted to kick this back to you, Neal. And what is it you want people to do? If people have been inspired by this work, if they've been scared by what's happening to somebody they know and love or themselves, if they feel motivated to get involved, but what would you like people to do?
So I can say with absolute confidence that sooner or later, everybody who's on this Zoom, or a loved one, or a friend, or perhaps most importantly, a pet, a dog or a cat, will develop a disorder which could be treated with focused ultrasound. So think about it, and you can help us by learning more. Go to the website, sign up for the newsletter, tell people about it, people who need to hear about it to increase awareness, and tell people who could help support the foundation that they should get engaged. And most importantly, on October 19th, go out and buy this book.
Well, I have to say, I've spent the last 5 years looking for the most promising developments at the bleeding edge of medical and biological technology. And I have to say that I've been really impressed. And I hate the idea that it has been medicine's best kept secret. I'm honored to be a part of this organization, and I'm thrilled to have a chance to talk to both of you about the great work we're doing.
Thank you, Jay. My pleasure, as always.
Maybe it's up to me to say thank you and good night. Then let's all go meet the neuroscientist and the novelist down at the bar.
Yeah, and let's forget about the nursing school at Pennsylvania Hospital.
Actually, let's put up a slide that shows all the contact information for the organization. There we go. That is, in case Focused Ultrasound Foundation is a mouthful, that's where to go. So thank you, gentlemen, once again. Thank you to the Atheneum. Thank you to Amy Jennis and everybody at the Focused Ultrasound Foundation for helping to put together a wonderful session.
Thank you all.
Jay, farewell. Bye-bye.
Bye.